First of all, let us recall the algebraic identities that we have done till now. That is, first one is a plus b whole square, then a minus b whole square, a plus b into a minus b, and then x plus a into x plus b. Now these four identities you've already studied in class 8, so it was just a revision of class 8 identities, and out of which the fourth identity I told you can also be treated as a splitting the middle term. We have done the questions based on this identity. Then we have a plus b plus c whole square, wherein I told you don't learn different separate identities by taking negative signs in these two places. Okay, so just learn one identity and accommodate the minus signs as and when they occur. Then we have a plus b whole cube, then a minus b whole cube, and in the last class we did two new identities. These were a cube plus b cube and a cube minus b cube. I hope children you understand one thing very well, that the sixth identity is a plus b whole cube, which is totally different from a cube plus b cube. A plus b whole cube means first we add a and b and then we do the cube of that number. Whereas a cube plus b cube means we take the cubes of two numbers separately and then add them up. Let's take for example, say a is 2 and b is 3. If I want to find a plus b whole cube, what will I get? 2 plus 3 whole cube, which is equal to 2 plus 3 whole cube, which is equal to 5 cube, which is 125. Whereas if I take a cube plus b cube, I will get 2 cube plus 3 cube, which is 8 plus 27, which is equal to 35. So these are totally different answers that we are getting here. So a plus b whole cube and a cube plus b cube are totally different terms. Similarly, a minus b whole cube and a cube minus b cube are also different. So in the last class we studied a cube plus b cube, and I told you two different identities for a cube plus b cube. In fact, the second one is derived from the first one only, but you have to remember it in both the ways, because when we do factorization we use the second one, when we do the calculations then we use the first one. Similarly, in the identity a cube minus b cube, for factorization we use the second one, for calculations we use the first one. Now the 10th identity that we will do today is a cube plus b cube plus c cube minus 3abc is equal to, in the first bracket we get a plus b plus c, in the second bracket we get a square plus b square plus c square minus ab minus bc minus ca. Now suppose I take one very simple identity, say x cube, I am taking a question, x cube plus 8y cube plus 27z cube minus 18xyz. So how we are going to factorize it? Can you just relate it with this identity, a cube plus b cube plus c cube minus 3abc? Can we say that the terms of this entire expression resembles this identity? Let us check out. The first term is x cube, so it is x whole cube. Second term in the perfect cube can be written as 2y whole cube. 27z cube can be written as 3z whole cube minus, now let me write the term in the form of 3abc, and then I will check out whether I am getting this or not. So 3 into a is, what is your a in this case? X, b will be 2y and c will be 3z. So 3 into a into b into c. So just check out, if you multiply this, are you getting 18xy? 3 2 is 6, 6 is 18xyz. So 18xyz we are getting. It means that the given expression is exactly of this format. Now what is the identity for this format: a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So now using this identity, taking a as x, b as 2y and c as 2z, I will get this expression is equal to, now I will be writing it in this format: a plus b plus c, x plus 2y plus 3z. In the second bracket, a square will be x square, b square will be 2y square and c square will be 3z square minus a into b minus b into c minus c into a. That gives us x plus 2y plus 3z into x square plus 4y square plus 9z square minus 2xy minus 6yz minus 3zx. So this is the factorized form of the given expression. So how will you realize by looking at the expression that you are going to use this identity? As for a plus b whole cube and for a minus b whole cube, I told you that when you look at the expression, there are 4 terms in the expression, like this. 4 terms in the expression, and out of the 4 terms, 2 terms should be perfect cubes, and then we see whether the other 2 terms are in this format or not, and then we apply this identity. Similarly, if I want to apply this identity, a cube plus b cube plus c cube minus 3abc, again there are 4 terms in this identity, and out of the 4 terms, 3 of the terms are perfect cubes. This is how you can make out by looking at an expression whether you have to apply a plus b whole cube or a minus b whole cube or a cube plus b cube plus c cube minus 3abc. Now I rewrite this identity, that is a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. It's easy to remember if you just put in your conscious effort once, you will be able to learn it. Now this is the identity. Now in this identity, if I just say, suppose that a plus b plus c comes out to be equal to 0, then what will happen to this identity? This identity will reduce to a cube plus b cube plus c cube minus 3abc. Left hand side will remain as it is, but because a plus b plus c is equal to 0, so I will put 0 here multiplied by this entire bracket: a square plus b square plus c square minus ab minus bc minus c. What will happen to the right hand side? 0 multiplied by anything will be 0. So I will get a cube plus b cube plus c cube minus 3abc is equal to 0. Or I can say a cube plus b cube plus c cube is equal to 3abc. This is known as the conditional identity, which I wrote as the last identity in the list of identities. So that is the last identity which is derived from the 10th identity only. This was the 10th identity, and here I have put the condition. What is the condition? That a plus b plus c, if a plus b plus c is equal to 0, then what happens? Then we get this result. So we can use this result only when you have this condition with you: a plus b plus c is equal to 0. Now in order to verify this identity, I will give you one question. Suppose I say x minus y whole cube plus y minus z whole cube plus z minus x whole cube. My question is, factorize it. Okay, now when you look at the expression, you will feel it is an expression containing 3 terms, and all 3 are perfect cubes, a cube plus b cube plus c cube format. Can I just write here, let a is x minus y, b is y minus z, and c is z minus x. Then this expression will become what? A cube plus b cube plus c cube. Now we say a cube plus b cube plus c cube is equal to 3abc if, what is the condition? That a plus b plus c is equal to 0. So whenever you see an expression in this format, first check out whether your a, b and c, their sum is equal to 0 or not. So let's check out what is our a plus b plus c. A is x minus y, b is y minus z, and c is z minus x. This and this will get cancelled, x and minus x, z and minus z, and this will be 0. So yes, our a plus b plus c is coming out to be equal to 0. Hence, I can say that this expression, that is a cube plus b cube plus c cube, is equal to 3abc. Now what is my abc? It is x minus y into y minus z into z minus x. Can I say that this is the factorized form of the given expression? Yes, very much a factorized form of the given expression. Now suppose I take another question. I say it's minus 24 whole cube plus 19 whole cube plus 5 whole cube. Find out the value of this. Now directly if you apply this minus 24 whole cube, means you are going to multiply minus 24 into minus 24 into minus 24. Then you will multiply 19 3 times, then you multiply 5 3 times, and then you add and subtract accordingly, and you will get the answer. But here, can you see that these are the 3 cubic terms in the expression? So if I say let my a is minus 24, b is 19, and c is 5, this expression will become a cube plus b cube plus c cube. But you know that a cube plus b cube plus c cube is equal to 3abc only if a plus b plus c is equal to 0. So let me check out what is my a plus b plus c. Minus 24 plus 19 plus 5, which is minus 24 plus 24, which is equal to 0. Because a plus b plus c is coming out to be 0, so can I say in my case a cube plus b cube plus c cube should be equal to 3abc. Now what is my a here? Minus 24, b is 19, and c is 5. It is still easier to multiply just these 4 terms rather than first cubing 24, cubing 19, cubing 5, and then adding and subtracting. So this way you will get some negative answer. After multiplying, whatever you will get will be your result. Similarly, you can do it with bigger numbers as well. Suppose the question is, say 99 whole cube plus, or you can say minus 19 whole cube minus 80 whole cube. Okay, so first we can write it as 99 whole cube plus minus 19 whole cube plus minus 80 whole cube. So now if I assume a as 99, b as minus 19, c as minus 80, and then if I check out my a plus b plus c is equal to 99 plus minus 19 plus minus 80, that gives you 99 minus 99, which is equal to 0. Hence a cube plus b cube plus c cube can be written as 3 into a into b into c. Answer will be positive, and whatever you will get on multiplication, you can get the answer. But don't you think it would be very difficult if you first multiply 99 3 times, then 19 3 times, and then 80 3 times, and then add and subtract? This is, as compared to this, it's a much better way of solving this question. Now let us do some of the NCERT questions of exercise 2.5. Now question number 11th, I think till question number 10th you must have already done using the previous algebraic identities. Now question number 11th is factorize 27x cube plus y cube plus z cube minus 9xyz. So here we can see 4 terms in the expression with 3 perfect cube terms. So we can first write them as perfect cube, a cube plus b cube plus c cube. So you know what is your a, 3x, b is y and c is z, minus 3abc, 3 into a into b into c. So that means this is exactly following this format, 9xyz. Now what is the identity for a cube plus b cube plus c cube minus 3abc? The identity is a plus b plus c, and the second bracket is a square plus b square plus c square minus ab minus bc minus ca. Therefore, we get the given expression now can be written as, you know your ABC, a is 3x, b is y and c is z. So write down in this expression we will get 3x plus y plus z into, this is a square plus b square plus c square minus a into b minus b into c minus c into a. So that gives us 3x plus y plus z into 9x square plus y square plus z square minus 3xy minus yz minus 3zx. So this is the factorization of the given expression. Now question number 12th I will be doing in the end. Let's do the other questions. Question number 13th. 13th question says that if x plus y plus z is equal to 0, then means you have to prove that conditional identity. If x plus y plus z is equal to 0, then prove that x cube plus y cube plus z cube is equal to 3xyz. So this you can use by using the above identity only. You can say, as we know, what do we know? That a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. We know this. Now they are saying given the condition x plus y plus z. So right now if x plus y plus z is equal to 0, then the first equation becomes x cube plus y cube plus z cube minus 3xyz is equal to 0 into this bracket, which is equal to 0, and hence this implies x cube plus y cube plus z cube is equal to 3xyz. That is your question number 13th. Now question number 14th, this type of question I have already discussed with you, that is minus 12 whole cube plus 7 whole cube plus 5 whole cube. Again there are 3 cubic terms here. So we can say let a is equal to minus 12, b is equal to 7, c is equal to 5. So let us first check out our a plus b plus c, which is minus 12 plus 7 plus 5, which is minus 12 plus 12, which is 0. So if this condition is satisfied, we say a cube plus b cube plus c cube is equal to 3abc, and hence similarly minus 12 cube plus 7 cube plus 5 cube is equal to 3 into a into b into c. Then you simply multiply them and you will get the answer. Similarly, you can do the second part of question number 14th. Now looking at question number 15th, it says give possible expressions for the length and breadth of each of the following rectangles in which their areas are given. So in the first question, if the area of a rectangle is given as 25a square minus 35a plus 12, you know it is a quadratic polynomial. Now that you have to check out which identity or splitting the middle term or whatever, you have done lots of questions. So this I am leaving for you to factorize on your own. Now whatever way you factorize it, but you know this being a quadratic polynomial, you will get two factors of this polynomial. So when you get two factors, one of them will represent length, the other one will represent the breadth. So basically you just have to factorize the given expression, and then both the factors will act as length and breadth respectively. Similarly in the second part, 35y square plus 13y minus 12. Splitting the middle term you can do, make two factors. One factor will represent the length, the other factor will represent the breadth of the given rectangle. Coming over to question number 16th of exercise 2.5. The question says, what are the possible expressions for the dimensions of the cuboid whose volumes are given below? Now the volume is given as 3x square minus 12x. This is the volume given to us. Okay. Now let's factorize it. What can you see here? You can see so many common things. So let us first check out common. 3x is common. We are left with x minus 4. So here you can see three expressions, 1, 2, 3. I can assume any one of them as length, any one as breadth, and any one of them as height. So I will get the length, breadth and height of the given cuboid. The second part of question number 16 is that the volume is 12ky square plus 8ky minus 20k. Here what can you do? We can first of all take the common part out. Can you see this k is present in all the terms? So take it out. We get 12, not even k, something else is also common. Just look at the numerical part, 12, 8, 20. So can I take 4 also common? 4k is common. So what are we left with? 3, k is out and only y square. 3y square plus 2y minus 5. Now when I split the middle term here, I need to find two numbers whose sum is equal to 2 and the product is equal to minus 15. So I will take the combination of 5 and 3, which might give me 2, but minus sign with 5 will give me minus 2 and minus sign with 3 will give me plus 2. So this is the best combination. 3y square plus 5y minus 3y minus 5. That gives you, now I am taking y common from here, I will get 3y plus 5, minus 1 common from here, I will get 3y plus 5. So we will get 4k into, here I can take 3y plus 5 bracket common and inside we are left with y minus 1. So here if I say this represents my length, this is the breadth and this is the height. In fact you can even interchange. No restriction on saying that this expression only represents length. Any of the three can represent length, anyone can represent breadth and anyone can represent the height of the given cuboid. So you have understood how to find out question number 16th as well as question number 15th. Now we left out one question in between, that was question number 12. Question number 12 says verify that. Now we have to verify that x cube plus y cube plus z cube minus 3xyz is equal to half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. We have to verify this. Verification means you can start from any of the two sides. I call this side as LHS, this side as RHS, left hand side, right hand side. So from any of the two sides you start the expression, go on simplifying it and get it equal to the other side. If you start with LHS, you should somehow reach RHS, or if you start with RHS, somehow try to reach LHS. So here I feel it's better to start with RHS, though we can do it with both the methods. So let's consider the RHS first of all. Now RHS is equal to half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. So let us open out the brackets here, x plus y plus z. Here I will get x minus y whole square is a square plus b square minus 2ab. Similarly, y minus z whole square is y square plus z square minus 2yz plus z square plus x square minus 2zx. Now what will I get? In the bigger square bracket, what do you observe? X square is coming twice, so I can write 2x square. Y square is also coming 2 times, so I can write 2y square. Z square is also coming twice, I can write 2z square. Minus we have 2xy minus 2yz and minus 2zx. Now this can be written as, now what do you observe in the bigger bracket? This number 2 is common throughout the expression. So let's take 2 out of the given expression. You will get x square plus y square plus z square minus xy minus yz minus zx. Now this 2 and this 2 will get cancelled and we are left with x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. If you compare it with the identity a cube plus b cube plus c cube minus 3abc, you get it to be equal to this. So can I write it in that format? A cube plus b cube plus c cube minus 3abc. So hence we have verified that this, we started with the RHS and we have reached it to be equal to LHS, and hence we have verified the given expression. Okay, now let's do some extra problems based on the identity a cube plus b cube plus c cube minus 3abc, which you already know. The identity is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Let's try to write the given expression in the format of the identity a cube plus b cube plus c cube minus 3abc, taking care of the plus and minus signs as well. So first term is a cube. Can I write this in the form of perfect cube? It will become 4x whole cube plus b cube can be written as 5y whole cube plus, now here there is a minus sign, but I will maintain a plus sign here because in the identity we have a plus sign. I will take the negative sign inside. It will be minus 4z whole cube, because when I do the cube of minus 4, it will come out to be minus 64. Then you have a minus sign here, so I will also maintain a minus sign here. I will try and write everything in this format and then I will match it with the given thing. 3 into a is 4x, b is 5y and c is minus 4z. Check out whether this term is exactly matching this term or not. X, Y, Z, yes, we have X, Y, Z. Minus and minus will become, these two minus signs will become a plus sign here. And when I multiply these two, 3 into 4 is 12, 12 5 is 60, 60 into 4 is 240. So I am getting plus 240 X, Y, Z. It means that the given expression is exactly following the pattern of this identity. So this can be written as a plus b plus c, that is 4x plus 5y plus minus 4z, but I am writing it here directly as minus 4z. Then a square is 4x whole square b square is 5y whole square and c square is minus 4z whole square, minus a into b minus b into c minus c into a, and then just simplify it. 4x plus 5y minus 4z into 16x square plus 25y square plus 16z square, because minus 4 whole square will become plus, minus 20xy. Now this minus and this minus will become plus. So plus 20yz, again minus minus will become plus 16zx. So this is the factorization of the given expression. What is important is to understand that which identity the question is exactly fitting into. Suppose I take one more question, say x square minus y square whole cube plus y square minus z square whole cube plus z square minus x square whole cube. Again the format is a cube plus b cube plus c cube. Now there is no minus 3abc here. We don't have 4 terms in this expression. We have just the sum of the 3 cubes, and for that we normally apply the conditional identity, which says that a cube plus b cube plus c cube can be written as 3abc only if a plus b plus c is equal to 0. So can I consider here a as x square minus y square, b as y square minus z square, and c as z square minus x square? So I can write here, let a is equal to x square minus y square, b is equal to y square minus z square, and c is equal to z square minus x square. Now I will check out what is a plus b plus c. X square minus y square is a, plus y square minus z square is b, plus z square minus x square is c. Now y square will get cancelled, z square will get cancelled, x square will get cancelled. So a plus b plus c is coming out to be equal to 0. Therefore, can I say this is my a cube plus b cube plus c cube? Can I write this as 3abc? Now 3 into a into b into c. What was our a? X square minus y square. B was y square minus z square, and c was z square minus x square. So this is the factorization of the given expression. Further, if you want, you can factorize it. X square minus y square can be written as x plus y into x minus y. Y square minus z square can be written as y plus z into y minus z, and z square minus x square can be written as z minus x into z plus x. So that is the factorization using conditional identity. We have done, I think, enough questions based on these two identities, and now I hope you can try out some more questions of this type.